You ready? Oh, still getting them. This is the Manet working group. We're going to get going here. Yeah, right. Thanks, Rick. It seems we already have a minute taker, so thank you for that. We're passing the blue sheets around. Please sign it. We could use the signatures. Of course, the note well. You guys have seen this in every presentation. If you have IPR, you need to bring it forward or let people know. When you're participating and you're making comments, please use the microphone and state your name. Try to state it clearly, as we have a new minute taker this meeting, and getting the names right might be more difficult than normal. Here's the agenda. We have 3 presentations today, along with an overview, and then we have an open mic at the end if anyone wants to talk about other issues or other things that we're not going over. Does anyone have anything to say about the agenda? No? So, working group overview. We have not met at the last 2 IETFs. This is the first one we've had in a while. We've had some interim meetings. We were on the we were put the task to finish up the documents that we had and get them out. We're very close to doing that. I'm not going to go over the whole issue and the whole happenstance with AOD VV2. That happened. If you'd like to talk to me after this, I'm more than happy to talk to anybody who wants to talk about that. We have DLEP is moving forward. There's still comments going on the list. It's still in AD review. AD review. Hopefully we'll get that cleared out relatively soon. The other one is on my plate is OLSR sec threats, the informational one. We had a last call. We didn't have really any comments on that, so I'm going to take it upon myself to do a thorough review and either write up the Shepherd document or not. I don't think it'll be a big deal, but I do owe them at least a thorough review of that. The rest are proceeding nicely, and the only other document that is kind of in limbo right now is the OLSR multipath document. There's been a lot of discussion between the author and Chris Dearlove, who's had a lot of really nice comments on the draft. It would be nice to have more eyes on that draft. It had passed last call. Chris got in some very pertinent comments right after that, so we pulled it back. We did it again, and it's still kind of in limbo. They're working out the details, and until they kind of agree and I agree with them, or Stan agrees with them, it's going to sit where it's at. So please read that draft and get comments back. I think it is a useful thing to have if we do it right. I don't want to break things when we do it. That's the main thing for me. We did get two RFCs since the last time we met, or actually since this year. ID-based signatures, that's been in limbo in the ISG for a long time. They finally got it through. And the DAT metric for OLSR v2 passed. So on to the next. Anyone have any comments or questions about the status? We missed a slide on our current milestones and deliverables. So I don't have a slide on that right now. I'll try to pull it up at the end. We do have some milestones coming up, and they're a relatively tight schedule. They include Manet management and kind of how we deploy Manets. Lots of people have been asking for that outside of our working group, and we've had 2 attempts at that before. and they kind of miss the mark on either end, either too generic or too specific. So we want something kind of in the middle. So authors of those two documents, I would encourage you to try to come together and work on that. I see one of them, James, here. Hopefully Ulrich and Thomas are interested in working on that again. But others are welcome as well. And the other ones are DLEP extensions, OLSR maintenance, or other extensions to OLSR v2, and the Manet multicast fib, which I'm going to give a presentation on. And I need more people participating in that, and hopefully this will help facilitate some discussions on how we structure this. So the next one.
You're up.
Yep. Okay. So we are, is this on? Yeah. We are tasked with designing a forwarding information base for multicast in Manet networks. So I'm going to be presenting a little bit about what we've learned at NRL with our implementation of SMF and our implementation of Elastic Multicast, which Brian presented a few IETFs back. Kind of the structure of our code. Go to the next slide. And kind of what we've learned and what's missing in the current SMF draft and how we can capture it in another draft and separate things out a little bit better. So real quick background, SMF is a simplified multicast forwarding protocol, and it's experimental in the Manet working group. It does Manet-wide broadcasts. It doesn't allow you to limit where the broadcast goes. It goes all the way through the Manet network. It uses CDSs, connected dominating sets, much like OLSR and other Manet routing protocols. It devotes a lot of the text in there to duplicate packet detection, and at the time we didn't know what worked and what didn't. It has both hash-based and ID-based mechanisms. And we found through practice that it depends on your network, your traffic, your devices, what you want to use. So we're kind of leaning right now to leaving them both in there as optional, because there are some networks you want to use hash and there's some that you want to use ID. It really depends on what kind of network you're using. With hash, certain traffic patterns will give you a lot of false positives, and you'll end up dropping a lot of packets that you otherwise would want. Similarly, with hash, you can end up draining your batteries on your mobile devices really fast. Alternatively, packet IDs is a big security hole. If you change that ID to somewhere in the future, and then all the other packets get dropped because they're in the past, way past, and nothing gets through.
Julius Krobachek, do the two options interoperate? Are they negotiated, or are they statically configured?
I actually have a slide on that. They're statically configured right now, and they do interoperate to some extent. There are caveats in that if you're doing duplicate packet detection with the IDs, the nodes that are injecting multicast into the Manet, be it gateway and reforwarding and rebroadcasting, they resequence the IDs, or if their sources in the Manet, they need to sequence the IDs. Otherwise, they're going to get dropped by the nodes that are going to do the ID-based forwarding, because they won't have an ID. But otherwise, if those injection points are taken care of, then everything would work. And there is some merit to doing kind of a hybrid where you mark the packets with an ID to give it a different hash, so you kind of get both, but you also get the drawbacks of both. And they're not intended to scale to large networks because you're flooding the entire network. So you really don't want to use this in 600 nodes, 1,000 node networks. It would be very inefficient. Some of the drawbacks of the SMF design is the design kind of munges the algorithmic control and what's actually being forwarded. So with that munging, we get a deployment and an implementation that is in user space, and performance suffers because of that when you're scraping all the packets up into user space and then sending them back down. So we want a better design where we have a forwarding bit that all the rules are clearly defined and how to control it is clearly defined, so that we can push that part down and keep the control up in user space, but have the forwarding take place more in the kernel space. Design-wise, we want to design it that way so people can implement it that way easily. Packets right now are disseminated, like I said, to the entire Manet. That's fine for small networks where everyone wants to hear all the multicast traffic, but in large networks, that's really not good. So there's also no group membership. You don't know if your Manet wants a specific multicast address or not, if anyone's listening or not. You just flood it. There's no rules for different multicast addresses, and that's an issue that we should address. CDS algorithms, currently the algorithms in the appendix of the SMF draft are only nominal algorithms. There are others that could be developed, but the ones that are there do not support multiple interfaces well. They're either on or off in terms of forwarding and flooding. There are other algorithms out there that can do multiple interfaces a lot better, but the algorithms we defined have not, and we should define the forwarding information base to support better control.
Rick Taylor, have you looked at using broadcast wireless links, so using the broadcast facility at the lower layer to assist the multicast as part of the SMF work?
Not quite sure I understand your question.
Okay, so if you've got a radio system which has effectively a shoutcast channel on there, so the ability to beacon out to all receivers that are listening, integrating that within your larger multicast topology. So the one packet effectively costs the same whether it goes to one endpoint or all of them. Right. So flooding suddenly actually becomes a cheap option. I wonder whether you've looked at integrating that into any of the SMF stuff so far.
We generally use the multicast on a radio if it has that, which
right.
would send it out to all of them.
Yeah.
If you have different interfaces, I gave a presentation a while back on how if you have multiple interfaces, it may be redundant to send it back out the same interface it came in on, because it might be a wired link and everyone already got that packet on that. It could be a directional antenna, a point-to-point link, and I don't want to send a packet back out on that interface because it's going to a guy who already has it. He sent it to me. The current algorithms don't allow you to do that.
Right.
So there are other algorithms and very simple ones that says, you know, if you have only one neighbor on that link, don't send it back out there. You can reduce it, but there's no algorithms. It's not designed with that in mind.
Okay.
So we should design the FIB, the forwarding information base, with interfaces in mind. And actually our SMF code has evolved in that direction so that we can do per interface forwarding based upon what interface is coming in on and some other stuff. Brian, my colleague, who's co-author, who's the main author of NRL SMF, would disagree with me on this last bit that forwarding rules are not well defined with multiple interfaces. And my point here is that in the SMF draft, there's a lot of text dedicated to gateways, how to resequence and forward over these interfaces, but there's not a lot of text regarding algorithmic control of what gets forwarded where based upon what interface is coming in on and then to go out on. And that's kind of what I'm talking about here. And duplicate packet detection is talked about on how to do it, but then various algorithms, you're going to want DPD to work either on the incoming interface or on outgoing interfaces or both, depending on how you're forwarding the traffic. Sometimes you want to do it on the outgoing interface because node A wants it to go somewhere, but this guy over here wants it to go somewhere else. So it's this, even though it's the same packet, you want it to go out a different interface, even though the first guy didn't want it to go. Next. This is just a quick overview of our NRL SMF and what it does. It's open source. It's at pf.nrl.navy.mil. If you want to get the source code, you can talk to me. It works with NRL NHDP. It works with OSPF, MDR algorithms, and we have that code as well. And it works with our OLSR v1 implementation. Our v2 implementation is not open source yet, just some process along getting it open. It has a remote control interface that we've defined. That interface is not defined in the SMF draft, because the draft just says you either flood or not, you use these algorithms or not. SMF is one big happy thing. Well, we separated that out. The algorithmic control is in the routing protocols or the neighborhood discovery protocols, and SMF is the forwarding engine, the forwarding bit. And we have a very simple API to control it. We want to expand on that because there's more things that the forwarding engine can do that we're not opening up the API to do. We know what we want, but we haven't defined that API yet. It's still very simple because the algorithms don't define those well. It's still a very simple, yes, you forward on all interfaces, no, you don't. Next slide. So this is a current SMF architecture. And one thing to note here is the SMF interfaces on the left, it can take in from multiple different interfaces. So you can have multiple physical interfaces and have them mapped to a single SMF interface that then does duplicate packet detection. It puts it out on various SMF interfaces that are also mapped to physical interfaces so that it can re-forward on a set, a subset, or all of the interfaces that you're running on. And you can have different rules associated with those outbound interfaces. So you can do things like resequence the ID. Next slide. So this is a conceptual slide, again, illustrating that we want to separate out the control from the forwarding. And there's another little bit here in that the forwarding information base should be a conceptual design on what the forwarding engine uses. It's not, it should be kind of like a table in NHDP, that it defines the table and how things operate, but it's not necessarily a physical thing, and it might be represented in the forwarding engine in some other way. We have an arrow going back to the control plane, and that is for our work in Elastic Multicast. We needed feedback on what new packets were coming into the network and what to do with them. Because if you're going to do group-based stuff, you need to know what's happening in your network and if you want to forward that packet or not. I'll get into more detail in a second. Next slide. So this is our current design. You have NHTP or another control algorithm up at the top. You have your SMF management MIB, and the MIB is kind of in pieces as well because some of it controls the algorithm, and that goes over to NHTP, and some of it controls what's happening with your duplicate packet detection and resequencing on interfaces and that sort of thing, and that goes down to your SMF instance down at the bottom. So the SMF MIB is kind of talking to both pieces because of how the SMF was designed.
Julius Krobacek again. I'm sorry, I had a moment of inattention, so perhaps you've mentioned it. Are you describing the architecture as something that has been implemented, or is that your plan for something that hasn't been implemented?
This has been implemented.
Yet? This has been implemented?
Yes, we have implemented this.
And the code is available?
The code is available.
Okay.
And we actually, we have some limited amount of the SMF management MIB available as well. James would have more information on that. But we did do some of the MIB design as well. And I say undefined algorithmic control here, even though we have our own API that talks, it uses, depending on your system, it uses different methods of talking from one instance to another of two different daemons running. But it's undefined in terms of the documents. We've defined an API that allows you to control the SMF. It's not as rich as we'd like. We'd like to expand that a little bit more to, go to the next slide. So we want it to change to something more like this, where there's a richer amount of filters and state in SMF that you're going to control, the forwarding information base, that you're going to control on this standardized forwarding information base API that would control what's happening. In the last slide, I said it was undefined. We've defined one, but it's not specified anywhere. And that's what we want to work on.
Rick Taylor again. Beg your pardon. This is more of a question to the chairs, and I know you're one of the chairs, and to Alvaro. Is working on an API a suitable thing for the working group to be working on. I understand working on the conceptual fib definition, very useful. And then as part of describing the fib, you could go into detail about, well, updates in these ways are useful. You're starting to drift off into netconfig yangy, oh, I want to update an information base realm, or we're getting into, oh, well, I'm using Unix domain sockets and this is what my C API looks like. And I'm not quite sure whether that work specifically is good for, should be done in the working group. Fib, yeah, absolutely, sounds great. API, I'm uncertain, and I'm looking to the chairs and Alvaro for this.
I agree with you somewhat. At a very minimum, we're going to have to just define what is allowed and not allowed.
Yeah.
In the same way we find in NHTP is what you can and can't add externally to it.
Okay.
So we might not, say specifically what the messages look like and how they're getting passed, but how it can be changed to point in a strong direction on an API that could be written to do these things.
Okay, that sounds reasonable.
Julius Krabacek, there's a lack of APIs in that space. So whether it happens within the working group or not doesn't matter, but working on APIs is a good thing.
Next slide. This is just a quick overview of Elastic Multicast, and I'm presenting this here because this is driving a lot of our work in terms of what we've learned about what we need in the forwarding information base. A quick recap on Elastic Multicast. It uses SMF to broadcast out all the multicast traffic. SMF informs a controller when new flows are happening. The controller will then send out ACKs to see who wants this, if anyone wants this. And if no one wants it, it ends up turning off that flow. So it will reduce the amount of flooding happening in your network. And it's a very simple method of doing it. It uses multicast joins and ACKs to see who's joined, and then it kind of, and it also takes into account dynamics. So if your network is very dynamic, it won't slow things down as much and it will let it flood around more. Brian has more on that in the previous presentations. The main thing here is that there's feedback and there's dynamic expansion and contraction of the multicast trees and meshes that are being built. Another key thing is that it's flow-based, and I'll get to that in a minute. Next. Again, just illustrating that for Elastic Multicast to work and other algorithms, one that it's not a multicast algorithm, but it is an algorithm, is reactive protocols need to know when a packet's going out and there's no destination, so they inform up higher. So something like this could work for a unicast routing protocol or be used by it. The feedback feature is kind of important, and the flow, I'm going to get what I mean by flow in a minute. So what do I mean by flow? Generally in SMF, we don't care about addresses. Is it multicast? Okay. Do we flood? Yes or no? It's really simple. It's too simple, and it's not efficient. So in our SMF implementation, we have an idea of a flow, and a flow contains a destination, source, port, protocol, and nominally an incoming interface. So you can categorize a packet based upon this flow, and that's kind of how it's being routed is based upon its flow ID. And its flow isn't going to really change. And we're still working on, we have this working. There are other ways to make this work as well. It can get really complicated. You can have a default way of, say, if it's multicast, I flooded out all my interfaces. I inform higher up. And then if it's a specific multicast I know no one's interested in, I drop it because it matches that source destination, and I know that no one's interested in that flow, so I just drop it. Next. So what do we do? What do we do with a flow? Do we just forward it or drop it? Well, we found that we don't just forward it or drop it. There are actually other things we want to do. And our implementation right now has you either forward it, you can forward it with a limited rate. So we have a queue, that limits how many packets can go out at a certain rate, that gives you priority, basically priority, or you can reduce the amount of flow. You get more control. We have a hybrid. I don't like the name of that, but hybrid, what that does is it sends out a fixed number of packets per flow, and then it shuts it down. And what that allows it to do is it goes throughout the network. Everyone gets the packet. They can do their protocol mechanisms that they need to do, and they either inform or not inform to allow Elastic Multicast to shut it down or not. So a hybrid kind of lets it go for a little bit and then shuts it off if nothing else is said. And then we can drop it. And then some other ones we've been playing around with are, we can queue it up for something like AODB. You can queue up a packet and wait for a fixed amount of time and then drop it. Or you can send an error to like no route. Those are ideas. Again, stressing that the forwarding information base should not just be a unidirectional flow of information. The forwarding information base should send stuff back up to the controller based upon the flow and what's happening. Next. And as I kind of hinted at, should we design this with only multicast in mind? Is it useful for other things? Are we getting too deep? Do we just scope this and not worry about it, or can we design it with other Manet protocols in mind and not specify, their use specifically?
Rick Taylor again. I spent the last 2 days basically in a lot of the netconf netmod stuff for completely unrelated reasons. I'm really liking the way you're going with this fib stuff. I like the idea of a generalized conceptual data model that can be extended out beyond just multicast, perhaps. I'm not sure how far that's going to go. But I'm very conscious of what's happening in I2RS, where they're trying to maintain these ephemeral models of things that are happening and using the netconf protocols to apply controlled atomic transactional updates to these. And there's a lot of work going on in there about managing this ephemeral routing state. And I'm just wondering whether, have you spoken to those guys about it?
We have not.
Susan Hares, lovely, knows a great deal about it.
We definitely need to interface with them.
I think we should be interfacing with them rather than inventing our own little bespoke solution and discovering that the big system integrators, because Manets always exist within a bigger picture. They're at the edge, but there's the rest of the system in there. And if we can use the same tooling, this is moving on from the MIB conversation, so this crossover to the management discussion is, I think we should be looking at some of the stuff that I2RS are doing with netconf to solve a similar but different problem.
Alberto Ratana, Cisco. Completely agree with Rick. One of the things that you may want to do faster rather than slower is, yes, Sue has been working with the NetMod guys quite a bit. There's still, I think, something lost in translation there for them to understand the requirements from a router, for example. So if you can come up with requirements, right? What is really needed from them, right? Then that's something that not only we can reuse whatever I2RS is trying to get out of that mod, but we can help I2RS work with that mod, right? So in other words, that's far from defined, whatever I2RS wants.
Yeah, and this presentation is, I mean, it's coming from our experience working with SMF and how our protocol suite has evolved, and we're kind of trying to capture that in a way that is more useful than just a one-off implementation.
Is it time for general questions yet?
About this, yes, I believe that was my last slide.
Oh, go ahead.
Oh, this was just a slide showing that we're looking at real code in kernels that are and how we can modify them to get some kind of forwarding engine in them in an easy way. That was all. That was the last slide. Yes, open for questions, comments.
Well, my first question is, let's say you had several multicast groups. would you expect to have a different instance of this for each multicast group?
Yeah, you would have different forwarding based upon the flow, and their flows being different groups would be different. So you'd have different rules based upon their various
Well, you
flows.
have different group memberships.
Yes,
But,
you different group memberships. The group membership part is part of the control algorithm that's going to control what groups get forwarded or not. But in terms of the forwarding base, it's just another identifier on a flow. Is the multicast address, the group address. So yes,
So-
you could flood certain group addresses. You could send other group addresses out a different interface. You can have different rules based upon the group address, but we consider them just the group address is just one key part of a flow identifier.
Right, but there could be some, well, I mean, I'm not sure, but maybe some danger. Let's say you had 500 nodes or 1,000 nodes in the network, and there were 3 of them were scattered, to get to be part of a multicast group. Then the total amount of control signaling to find them somehow could even be worse than just flooding. I don't know, depending on the mobility. And besides that, well, for instance, the original motivation for SMF, I think to a large degree, was because flooding is so inefficient, and NPRs and CDSs can reduce the amount of control traffic by upwards of 60%, for those networks.
Right. So to give you a quick overview, real quick, the Elastic Multicast work we did worked exactly how you're saying. It uses CDSs. It uses the default SMF algorithm. It gets sent out. It would use the hybrid method of forwarding out the packets, so they would get sent out. Then the controllers would be told, hey, we got this multicast packet, what do you want to do? And they would send out messages. The control would send out extra messages using NHTP and other messages to say, does anyone want this stuff? Do you want to join this group? And if no one said yes, they would turn that flow off. They would turn that group off. And as people said yes, they would keep it on. They would add a rule to do it. Instead of a hybrid approach, they would do the CDS flooding. So at worst case, it would work the same as CDS flooding. Best case, it would prune off everything and it wouldn't flood at all.
Can I ask at this point that we're over time? So can we either pick this up after the meeting or take it to the list?
Yeah, that's fine. Let me just make one more sentence, which is that, if it turns out that managing a lot of group memberships is complicated, it would still be nice to put into effect what you've got just for the basic flooding operations as you might say a first step that's almost universally useful.
There is a draft Elastic Multicast that Brian has written, and it's out there. You can read that. We decided to step back to build it in the right way instead of just moving forward with it.
Okay.
So.
Okay, while we're transitioning to the next presentation, I want to ask, where is the blue sheet, and are there people who haven't signed the blue sheet? There are lots of folks that haven't signed it. Do we know where it's at? Can we start it again? I can do that something. Okay, so I wanted to give a quick update on DLEP status. See, it was quick. As we said earlier, DLEP is in AD review. The AD did come back with comments. We've addressed those comments and posted a DLEP 23 yesterday, day before. One of the two. The biggest change was to use RFC 5082, or is it 5802? I forget which. It's GTSM on the TCP session. There's some discussion about that going on the Manet list right now, and we will follow up with that discussion. I'd like to follow up with that discussion before we give it back to the AD. Okay, so that's where we're at there. The other issue is that we we had disallowed some data items on destination announce response, and an item was brought to the list that we should allow the same data items on destination announce response that we allow on like desktop, and that's been changed as well. So next slide, please. And in terms of the credit extension, it's also in AD review. The AD came back with comments. They have not been fully addressed yet, so it has not been resubmitted to the AD. The biggest issue revolves around credit window synchronization, and that's work in progress. So next slide, please. The other thing I wanted to talk about was an extension that's not yet been submitted to the working group, but one that we're chartered for. We had talked for a couple of IETFs now about DLAP extensions for metrics by traffic class, or essentially metrics by DSCP code point. I've got that. I'm writing that. It's not ready to post yet. Expect a draft, a 0.0 draft that's in the next couple of weeks. And once we get that posted, we can talk about it on the list, make the necessary changes, and try to drive for, first thing would be accepting it as a working group document, and then we'll go forward. But the work is in process. And I think that's all I've got on DLAP. So, but I see people running to the microphone. So,
Rick Taylor, can I just say I have a couple of personal drafts for all other DLAP extensions that once DLAP is finally rubber stamped, I will revisit. They've currently expired. I want to bring them back to the working group and ask for adoption for them, just as a heads up.
okay, since we're rechartered for DLAP extensions, that would be fantastic.
Luber, 2 comments. So metrics by traffic class sounds interesting. I'll be interested to see how you manage the mapping of traffic classes to queues, and because usually it's the queues that have the metrics, not necessarily traffic classes, because you have multiple traffic classes mapping the same queues. So that'll be interesting. And have you thought about credit by traffic class or by queue?
Let's see. Have I thought about it? No. Does it sound interesting? Yes.
Okay. I've seen some folks I'm working with have a couple of thoughts on that topic, as well as some other extensions. So I would expect them to come in also between now and the next IETF. And maybe they'll line up nicely and we can just collapse them.
Yeah, that would be fantastic.
Thanks.
Okay, any other questions on DLAP? Wait, one of the authors has a question on DLAP?
Yeah, this is it's Rick Taylor again. It's not a DLAP question, it's a process question. Following on from Lou's comment that he and some of his guys he's working with also have some extensions. I'm not sure how familiar people are with the inner workings of DLAP. Of course, you've all read all the drafts because you've come to the working group. The extension mechanism is within DLAP is both parties announce the extensions they support as part of the negotiation at session initialization. Does the working group want an extension per document, per draft, or are you happy to work on a draft which says, and this draft introduces 3 new extensions that each may be independently provided by an implementation? How do you want this managed?
From my perspective, and I haven't looked back at my chair. You hit me cold with this question.
It just came to me after Lou said he's got 3 up his sleeve. So
it's whatever makes sense. I mean, I could see a document. Please.
Hi, Lou Berger. My experience is having a independently implemented thing per document really helps when users and vendors are trying to understand what it is that they're actually delivering or requesting in an RFP.
That's a fair point.
If it's going to be delivered as a set, sure, do it in the same document, but call it one extension.
That's a fair point.
If you're going to have multiple extensions,
yeah, I agree with you.
Or if they're all required together. You know, if you have 3 extensions, but an implementation is required to implement all of them, sure. But if they're going to implement only one of three, separate.
Just as Rick Taylor again, just as a follow on from that, I understand. I want to avoid having optional things again. So I have one document with 3 extensions, which kind of go hand in hand, but actually I'm only supporting one of them out of the set of 3. So I think a little bit of care needs to be taken with this.
Okay. I'd like to pull, Julius Krabacek, I'd like to pull in the other direction. I like big documents that have a single introduction and you understand what you're reading and there's an order, and as you're implementing you get all the background in a single document rather than chasing pointers between hundreds of documents. And so I would like to encourage the group. I know it's more difficult for the group and it's more difficult for the editors, but I would like to encourage the group to make big documents with plenty of content and few of them.
I think, as I interpret the point Lou made, it's that as a vendor, it's hard to go to your customers and say, I support sections 3, 8, and 17 of RFC 8989, right? That's not really a good deal. It's not a good idea. So if you're going to write the document, you either support what's in it or you don't. So it lends credence to the idea of, from a functional perspective, get it down to something that's boundable and quantifiable, and then publish that. And you need to publish multiple documents if you're doing multiple things.
And he's absolutely right, and I'm right too. And he's pulling in the direction that's convenient for the vendor. I'm pulling in the direction that's convenient for the implementer. You're probably pulling in the direction that's convenient for the chair, and we'll end up at a point that suits everyone or nobody.
And if we're lucky, we'll pull it apart.
Once again.
No, I'm just, was a poor attempt at humor.
Luberger, I'm pulling in the direction of the user,
Yeah,
not of the vendor. I actually care more about from the user who says, I want RFC XYZ because I want function, that very function. So when I specify an RFC, I don't know if there's too many options, I don't know what I'm going to get. And what's really cool is if you have enough options, and I've personally been involved with a spec that failed this way, if you have too many options, you can get 2 vendors that say they implement the same RFC and they don't interoperate or deliver the same thing. That we're not doing our job if we do that. That's the real issue.
Rick Taylor again, just taking up on Julius's first point, which was I like a big document because I like all the intro stuff in one place. It is in one place. It's called DLEP. We're talking about extensions to a core document that describes what it is, how you do it, what's the minimal you must support. So I think we've kind of satisfied that requirement. The rest are really appendices published after the date for loose reasons, which I do agree with.
John Dowdle, I'd like to speak from the point of view of the poor people who have to specify what it is that they're buying. Because I don't think I've ever seen a product listed with supports a section of an RFC. It's either an RFC or it isn't. And I think actually the people specifying have limited technical expertise and they go, right, so do we use this document or do we not? So I personally would like to see it split out as several RFCs. And also that means they can be worked on independently. We can say yes or no to each one. And it becomes easier to work with altogether.
okay. Points taken. Any other questions? All right. Thank you. You got 16 minutes. Yeah, go ahead. 16.
Okay. Yeah, I'm Simon Wunderlich. Thank you for giving me the opportunity here. I'm talking about Meshmerize. It's a mesh routing protocol with network coding. Next slide, please. So this is work from Sri Krishna Pandey, who is also in the audience, and myself. We are PhD students at the Deutsche Telekom Chair of Communication Networks in TU Dresden, Germany. Myself, I'm with Batman Mesh software, which you might have heard of. I'm working on that for more than 10 years now. It's also part of a Linux kernel. And we would like to introduce our research project called Meshmerize. We would like to get your feedback. For us, it's the first time at the IETF meeting. And we would also like to understand if this is like material for RFCs, how to split that, how to publish it, and maybe also get you to collaborate with us. Yeah, so feedback would be very welcome. I plan to do this presentation in 10 to 15 minutes, so it will be very brief. But yeah, I hope you can get a glance. So next slide, please. Okay, so basically, Meshmerize is a multipath opportunistic mesh routing protocol, which is based on network coding. We want to exploit the broadcast nature because many routing protocols, which are also standardized on the use unicast routing. And one of the innovative things is that we just don't have repeaters which just forward messages as they are, but we have relay nodes which recode using network coding. I will explain that in a minute. So our objectives is mostly high resilience to topology changes and, if possible, also aggregate throughput. I think that's already known from other multipath approaches. Okay, next slide, please. So very brief introduction to network coding. Typically, in a Wi-Fi network, you send just packets. They all have a sequence number. And if there are lost packets, then you would just reset them based on some kind of feedback. In network coding, you just don't send the packets as is, but you combine them. You create linear combinations of these packets. You attach a vector, a coding vector, which describes what kind of packets have been combined and how. And on the receiver side, you can solve a linear system and recover the original packets. And in that way, you don't need specific retransmissions. You just need a sufficient number of packets received. So you can solve a linear system. All right. One interesting feature you get with that linear combinations is recoding. So you see we have 3 nodes here, encoder, a recoder, and a decoder. And the encoder sends 2 packets, which are linear combinations. And as you can see, the recoder sends a combination of these 2 packets it received. So it can create unique, new, but still valid information packets, right? And every recoder can create different packets, not only from by, for example, randomizing or choosing specific packets, but also a recoder might have got different packets because some of them were lost and they only got some of them. We have another slide here. Next, please. So you see here, I think that let's take in the second and the third on top and combining those to a new packet, which is then sent and received by the decoder. Okay, next, please. So what is good about network coding? Network coding, it's resilient in chaotic networks. We require low feedback. We just need to make sure that the other participants receive enough packets. We are pretty independent of arrival order. And I think it's very interesting to apply all these characteristics to mesh networks in 2 ways, multi-hop and multi-path. We will explain that next, please. So first thing is multi-hop. A typical problem if you have multiple hops is these numbers show the probability of the packets received from A to B or A to C or A to D. And on each link, you might lose the packet. And if you lose it, the original sender has to send it again. So the probability multiplies. Next slide, please. And with recoding, we don't have that problem because we can recover part of the information from the intermediate hops. All right, so the probability rises to the probability of the weakest chain. Okay, next slide, please. The other feature which we have is that.
Excuse me.
Yes.
Julius Krobacek, could you come to the previous?
Yes.
I don't understand your figures on the left-hand side. You're assuming no ARQ here.
Yes, this is
Okay.
assuming no ARQ.
So how does ARQ? So assuming ARQ, you would get widely different figures.
Yes, it would
It would
look
be
very
linear.
different. I don't have the exact numbers in mind. So with ARQ, it's much better, obviously. But with network coding, it would still be a little bit better. And recoding is especially interesting if we have multiple paths, which we will come to in a minute. Okay. So first thing, use network coding to leverage the broadcast medium. We don't just think in one single path, we think in corridors. So there might be some links which are metric-wise very similar to the best path. And we think of every transmission as a custom multicast. We decide which nodes on the way should take part of that way based on some metrics. We don't go into detail, but it could be airtime, for example. And different relays will hear different packets. So we also made some experiments and we saw that they just get different packets and some of them are lost and these are not really correlated. Okay, next, please. So another thing what we can do to leverage the network coding characteristics is that recoders only send out packets when their rank increases. The rank is the number of linear independent packets. So think of it as you only send out a packet if you get new information. If you get the same information, which is linear dependent to the packets you already have, you then don't send anything. And the funny thing about that is that you can implicitly avoid routing loops. You don't send anything which is already known, which might be interesting also for the first SMF talk, which we heard today. Next slide, please. So for multipath, so if let's say one of the link fails immediately or fastly, we don't have to wait for the periodic updates. We can still use the other paths which are already set up to forward for that specific multicast transmission. And we will have feedback which tells us, okay, please send me some more information packet, and this will control how many, which recoder sends how many packets. We can also specify the size of the corridor. So if we make the corridor very narrow, we will be at the unicast case, which we already know. We can also make it very wide to be more resilient. All right, next. We did some experiments. We are also in the process of implementing all of that ideas and see how it works. This is our chair in Dresden, and we just had the source, destination, and 2 relays. We were comparing with a Batman protocol, and these had very bad links, and we were comparing UDP as far as I remember. And you see with just using the second relay gives some little bit of improvement. Doing recoding on the first relay gives some improvement, and using both relays at the same time even gives more improvement. Yes.
Julius Krobacek, Batman is doing ARQ here.
I think we were configuring as multicast, but I have to check. I didn't do these.
Okay. And do you remember roughly the packet loss rate you had on those? Was it 0.2 or was it 0.99?
I remember that we were using 1 megabit per second. It was already bad, but I can't recall the exact numbers. That's just a simple scenario also to give an idea what we want to do.
So, Rick Taylor, sorry, for this test, that is a single stream going from source to destination.
Yes.
You're not running a stream in the,
It's a UDP stream, yes.
but a single UDP stream across the network from,
Yes.
from S to D.
Yes. Mhm.
Sorry, follow-up question. I'll let you finish and then I'll ask questions.
Okay. So that's, yeah. So to summarize, what we think we can do is to exploit the broadcast nature of a wireless medium. We can improve error resilience and possibly improve network throughput as well. Maybe not if everything's on the same channel, but if we have distributed channels, for example. We also eliminate the need for explicit scheduling and pathfinding, which we would normally have to do if we do multi-path routing. We are currently in an evaluation phase. So as I said, there's not really something written down. We are doing code. We have routers scattered and we are trying. All right, next. So that's about it. Again, I would like to hear your feedback now or later and see how we can work with this group.
Ben Schwartz, Jigsaw. I've noticed that a lot of mesh routing systems seem to work very nicely with sparse meshes where each node can see a few other nodes and collapse completely under radical congestion in ultra dense environments with, you know, like this room, if we all had a mesh node in our seat and we had total visibility. You get these, for example, situations where somebody emits something and everybody else tries to echo it simultaneously on the same wireless channel. So how does your system fare in dense node environments?
So we didn't implement that, but for the standard metric which we would think of, and you have the source and destination are in the same room, we would say, okay, the metric to the destination directly is lower compared to going to another recoder, and we would make the corridor as narrow to go to the receiver directly.
How would you know that?
So, for example, we can find out the metrics, like hop count is the simplest one, but we think about airtime, like what kind of modulation rates do we currently use, and this is given from the selection algorithm, which are usually implemented in the wireless driver. Like, can I reach that neighbor with 1 megabit per second or maybe 54 megabit per second?
John Dowdle, thanks for your presentation, really interesting. Can you go back to the slide where you were, one of the slides early on where you were striping the data across the outgoing packets? One before, I think. That's up on there, yeah. So are you putting data from one particular of your X, Y, and Z in more than one packet that's going out between S and R?
Yes, so we are packing all the data. We are multiplying that with coefficients and putting the information from multiple packets into one packet.
Right, okay, so what I'm getting at is the data from X, Y, or Z only sent once across the link S to R, or is it sent multiple times?
There will be different combinations sent multiple times. So if you just send one packet, you can't compress 3 packets into one packet.
Right.
Right.
What I'm concerned about, if you lose a packet between S and R, you've lost several X, Y, and Zs at the other end. No? Okay.
Yeah,
so it's all mixed up, but yeah, it's a question of whether that's recoverable or not. Yeah. Yeah.
Yeah, it's coding, so we can recover the original packets through coding, but that's the idea. There's also extensive literature. We are thinking about employing random linear network coding, if you want to look that up. Right. Okay.
So, Julius Krobacek, that's really cool. And it's really cool. And the bit that is not entirely clear to me, are you actually hacking at the MAC layer? Are you using the 802.11 MAC, or did you actually implement your own MAC layer that implements network coding?
So we are using 802.11, but we are modifying the drivers, for example, to be able to send packets and any modulation rate what we want, or we turning off the ARQ. So we did some modifications,
Okay, sure.
but we are using the 802.11 max as
So
layer.
the chip is still running its original firmware.
Yes,
Here.
yes.
Okay, thank you.
Thank you for the presentation. Justin Dean. I'm working group chair, but I'm participating now as a participant. I think it's really interesting work. I see this type of work becoming what we're doing in the future. And I'm glad you're at the IETF. I'm glad some people from Batman are finally at the IETF. I've been trying for a while to get you guys to come, so that's nice. The piece that I find really interesting is how this works with what we're scheduled to do right now, which is a fib, and if that interfaces at all, or if we should design certain features into a fib that this would be able to take advantage of, or not.
So you mean how to split that?
In my mind, the one that came to me was I had listed, forward, drop, queue, hybrid. Well, this is another one. This is encode.
Yeah.
Shuffle. It's another thing to do that we hadn't thought of. So
okay, yeah,
that would be interesting to consider.
But thank you. But it would definitely be good. But I didn't really follow the IETF process so far, so I'm not sure. I would be happy to integrate that as well.
Hello, John Trembeck. I was wondering, does this involve metric propagation like link state or distance vector? Does it work without that? I didn't quite get that from the presentation.
Yeah, as a Batman guy, I was thinking about distance vector and propagation to propagate the metric, because we will need to have metric to define these corridors, obviously.
Okay, so it still has propagation like other mesh routing protocols, but this is just a better way to send the data.
Right, right. So we are thinking about implementing a proactive protocol, which is out of band, pretty much like Babel or so all this are. And yeah, when we have beacons which are flooded, propagating the metric, and then we can make up the path.
Rick Taylor again. Do you have any data on? I understand with the network coding, you add overhead in order to add the redundancy within the
Yes.
mathematics
Mm-hmm.
to get the error correction in there. But by doing that, you overcome the failures due to dropped packets across the network.
Mm-hmm.
For a 100 kilobits input stream, how much do you multiply out the packet, and how does that offset against the chance of dropping? So what rate do you get at the far end for your 100 kilobits in? I'd love to see a graph of, oh, well, if we use very heavy error correction coding, so we're doing massive increase in packet size in order to get all that redundancy in there.
Yeah.
We don't drop any packets at all, and we drop any, that gets to the far end, but it comes at a 10 times cost as compared to very little networking coding, but guess what? We actually lose some data along the way. That would be an interesting graph as far as I...
Yes, so we should probably have something later on that. Basically, but RLNC is a rateless code, so we can easily say, okay, we want at 100% or 200% redundancy. Yeah. By default, we will, or in the best case, we can just send as many input packets as output packets, just coded.
Right.
And if all of them are received, then it can be decoded, and the only overhead you will have is the coding vector, which is attached in the beginning.
But you lose the redundancy by doing that. So
yes, and we would decide on how many extra redundant packets we send dynamically, which would also be part of the feedback. And this,
So you'd run that across the control plane as your sort of distance vector. Here is my metric propagation happening, and then I think we should probably take
yeah,
this
but
offline.
that goes a little bit into detail. But for example, the rate control algorithm from a Wi-Fi driver also tells us what is the drop probability, and we can take that into account. We can also say, okay, we have 2 or 3 neighbors where we send. So I will tell my neighbors through feedback, hey, I have, let's say, 9 packets, and each of you should send 3 of them recode, for example.
I think this is really interesting stuff. And with my DLAP author's hat on, can you stop looking at the Wi-Fi driver and maybe look at using DLAP, and then it's portable to lots of other different radio systems.
Yeah, that's
It's
actually good.
we've almost got it published.
All right, I will look into that. Thank you.
Thank you.
Okay.
Thank you.
Yes.
Hi, I'm Guido Iribarren. What about latency? How is latency affected in this small test?
That's a good question. So usually, if you use the coding in a blocked scheme, you have to wait for, let's say, 10 input packets before you can start coding them and sending them out. But there are also other approaches where you, for example, send the packet as is immediately and just send redundant packets at the end. That's called systematic coding. In that case, if you actually receive a packet, then you can push it up immediately, and only if you didn't receive, then you have to wait for a redundant packet.
Hi, I'm Jim Nguyen. I'm just wondering if you have you tested in a larger scales, maybe like 20 nodes or I don't know 50 nodes, something like that, as first things, and apply some kind of Manet characteristic like mobility, disruption, delay, packet loss, and also latency as well.
Okay, so short answer is no and no. We have implemented or tested it on 4-node networks. We're also in the middle of simulating, and if all that goes well, we will probably get 50 to 100 nodes to make a bigger setup just in the university. At that point, it will be static. And we have some ideas to also test a little bit with drones and stuff like that. But that's not, yeah, we didn't put too much thought into that yet.
Oh, okay. All right.
Okay.
Okay, thank you. That was our last presentation, so we'll have a quick open mic if anyone has any comments or questions regarding Manet other than what we've talked about or what we've talked about. Now would be the time.
Julius Krabacek, and I wish to apologize for 2 things. One is that I didn't read the 2 management drafts, and the other one is that I'm going to repeat something that I've repeatedly said on the mailing list, and that I will keep repeating until the chairs call security and get me kicked out. There is some really remarkable work that is being done in the home networking group on autonomous management of networks. I've given a talk on that on Monday, it was. We in Paris have been trying to experiment with the HomeNet technologies in a mesh environment. It works surprisingly well. It needs some work. I think it would be a great pity and a great wasted opportunity if the management work for Manet was done in isolation of the work that has been done in HomeNet. What I'm hoping for is a Manet configured management protocol that interoperates with the HomeNet stuff in some weaker sense, not full interoperability. What exactly can be achieved is not yet clear to us. We've been discussing that with Henning Roge and Marcus Stenberg. And well, I will keep working on that, and I will keep repeating that at every opportunity.
And I would say that sounds like, I absolutely agree with you that the work should not be done in isolation. It should be done in conjunction with HomeNet. B, we're looking, as the IETF always is, we're looking for volunteers to help us. So would you like to take that work on with Henning Roge and some of the other people?
I have volunteered and I am working on that.
Fantastic. We look forward to it.
Yeah, I actually saw your talk in HomeNet, and there were some really interesting pieces there about auto configuration of addresses and how it was working. So I'm interested to talk with you after this as well and interact with you there.
Jérôme Beauvais, Arma Suisse. There is a lot of research work going in the direction for mobile networks to consider the position of the nodes in order to anticipate the routing, the connections between the nodes. Has this been already been considered, or is this something interesting?
I've had talks with authors of OLS-RV2 in the past regarding position. I think it's something that we would be open to considering. The first thing that comes to my mind is how you can augment OLS-RV2 with position information put into TLVs attached to addresses. That seems like it would be relatively straightforward, and then you could select NPRs or next hop neighbors based upon that. That would be interesting work. I don't think we need to make a whole new protocol. I think we got the pieces that we can build on what we have, and also allow it to be used by other protocols that might come along later. So yes, please write to the list. Please, if you have questions about our Manet architecture and what we have right now and how that might fit in, please ask. There are people out there, myself, others, who
We
can
had
help.
an in-house project with drones, actually, where we know exactly the path they are flying, and we had already good results in increasing the reactivity of the Manet with such algorithms. So we could also share our work for the working group in order to standardize something like that.
That would be great. If you want to try to put together a presentation for next IETF, that would be even better.
Okay.
Rick Taylor again, just adding my 2 cents worth. I would love to see something informational draft in the working group entitled Augmenting Manet Routing Protocols with Geographic Information or Position and Vector. So.
Well, thank you all for coming. I'm glad to see some old faces since it was a year ago since we last met. So please stay after talk. We still have some more time before the next meeting, and I'd like to go to the side
Just before you close, sorry,
yes.
Rick Taylor again. Are we going to meet in Seoul, or is this going to be a once-a-year thing?
I have to check my schedule. The plan, Alvaro might want to stand up and speak to this. Before the recharter, we had a lot of work that was kind of bogging us down in terms of getting new work. If there's enough participation on the list and there's enough new work happening, we're going to meet in Seoul. We need to keep moving. We have a very tight schedule on our deliverables. There's lots of good work that's out there, and I'm happy to see new faces as well to kind of energize the working group and move us forward in a good direction. So I think once a year would be too little. I think 2 a year might be okay. Depending on, like I said, depending on activity on the list and work that will be presented and worked on at the next IETF.
Sorry, second point I've just been reminded of. I've got a draft up my sleeve I've been working with Lottie for 5444 extension. Is that sound like a working group kind of thing, or have we moved beyond that now?
Talk to me after this.
Okay.
Okay.
All right, so officially, I guess we're closed. Thanks everybody for coming. If you want to hang around and discuss things Manet for another 15 minutes or so, we'll be happy to do so. But thank you. There was no food thrown. More than 2 of them?